Hello, everybody. This is going to be a quick video where we talk about attempt to address some of the repeated code that's happening in MUPL, especially on the challenge problem. So let me just read this question from one of the students just completely. I see the benefits of having functions for getting different fields of structs instead of just using car encoder a lot. Making sure that you have the correct types is nice, is in a nice way, but it seems like sometimes you really want to recursively perform a process on each field. When I was working on the challenge problem, I ended up with lots of code repetition. I couldn't figure out how to abstract away because of the field names like this. And then there was some amount of the solution, so I just took that out. Is there a nice thing we can do here that I'm missing? Is this use case of designing an interpreter just unusual, or so we wouldn't have this repetition, or is there another way I should be doing this? So I thought this is a really good question. I had the repeated code too. Those of you who haven't completed the challenge problems, the challenge problem for MUPL Homework 5, I highly recommend it, or when you get to that point, come back and maybe watch this video when you're done. It talks about you're going to have to basically, instead of grabbing the entire environment for your closure, get just the subset that you need and find the free variables. And so there's two parts to this. One is after building eval under n, you're going to have to build eval under m for the challenge problem. And this has got a ton of repetition when you build this. And this repetition doesn't bother me so much. It seems like an artificial byproduct of this being a university course assignment. If you were building this for real, what you would have is, I can certainly see building eval under n at the beginning, and then somebody's like, hey, like maybe we should stop wasting so much space on our environments when we're building up our closure. Why don't we just grab the subset of what you need? And you would maintain the original until you got the free variables part where optimization working, and then from then on, it's not like you would maintain both of these versions of code under real circumstances. You would build the free variables optimization, and then no one would ever think about the other one. It would be squirreled away in some Git history, and that would be the end of it. And so like this whole code repetition doesn't bother me so much because you would just replace one implementation from the other normally. The compute free variables part, on the other hand, that's definitely something where I think what this person is getting at is coming along. I have built an abstract syntax tree in my past life many moons ago. This was in Java, an object-oriented programming language. And when you have an AST like this, where it's got like the language, the fundamental language that you're using or that you've built for your project in it, you just often want to run the tree and perform some function, right? Like there's just a bunch of times when you just need to crawl the tree and do something. But you don't want, and it's really well suited, you could build it so that every single new feature that you wanted was in the sort of core base subsystem of your entire thing, the abstract syntax tree, but that seems wrong, right? You don't want every one of those operations to sort of like get into the abstract syntax tree. That wants to be as small and as pure and as basic as possible. So what you end up doing, or what I end up doing is something called the visitor pattern, where the data structure basically provides all these accept methods, right? And there's some car element visitor, or what would be your AST or your expression visitor for MUPL, where it would get a visit call for each of the different types, right? And each one of these would call visit on itself, and this guy would call it on all of its children, and then on itself. And so over here, when you're actually using it, you would write this thing that would print them, for example, and every single one would get its own method. You can also build a default implementation of this that does nothing, and then just overlay, like, let's say you just want to crawl it and find all the wheels, right? Or however deep it is, or I want to find all the int literals for something that's like an AST. Well, you could just implement that one, right? And so that's nice, and you would use it this way. And so how would we do that in a functional, how do we achieve this sort of thing in a functional programming language? We're probably not going to get this automatic separation of the, of the different types, right? Because that's not really how your functional programming language is going to work. By the way, bonus, I just put these overrides on the side so it would fit. I normally write them like this, just a little aside. but how do we get this kind of feature in a functional programming language? So another way to describe it is how I made myself feel better about it. All this code reputation is part one, build a higher order function like map. This is what my map looked like. You sort of like call proc on the function itself, and then you call proc on, call this higher order the function that gets passed in called proc on all the sub expressions. Now you could have also done it on, the names of the variables and like, so in function, I could have done it on the optional name and the formal parameter and name and all this other stuff, but I just chose to do it on expressions. So, but this is the general approach. A friend of mine used to make fun of me. If I ever needed, I would always build some piece of reusable code, even if I was only going to use it once. I think that this would get used more than once for an abstract syntax tree of a language that you're building. Like it's not unheard of that like whatever you build here will be used twice. So like once you're done building it, then let's use it. Oh, this is going to be really easy. Like compute free variables is now calling map with this toChallenge function I wrote with the expression. That simply does is if it's a function, change it into the challenge form of the function with its create free variables. If it's not a function, just return E. And so like now I feel really good about writing map. I can use map later. And like that leads me to my part three, which is convince myself that create free variables, which is the real sort of challenge, is why I felt okay with providing you with map, is like the specifics here are in create free variables. I could convince myself that this would be good for fold, right? And so let's talk about this sort of specifically. There's some realities about fold. Like the order required is really specific for create free variables. There's just times when it's really easy. Oh, like I found a variable, like add it in, like that's not so bad for fold. But then there's the handling of a let expression or the handling of a function where you got to do things in just the right order, it seems like. And so for it to work out, because you got to add these before you remove the function name or whatever. And so in some ways, the execution order for create free variables seems pretty good. In other ways, you feel like it'd just be easy. Like even if I had fold, it wouldn't, like however somebody naturally built fold, like it wouldn't match up with exactly what I needed for create free variables, or I'd have a tough time figuring out exactly which incantation I wanted, and I just build it anyways. But like like the more I think about it, like if you just built fold such that it worked for create free variables, that would not be the worst ordering. Like sort of default ordering is just the way in which free variables works is kind of how like execution would work, how you'd kind of want to build a tree would work. It seems fine. You are kind of left with, all right, so like even if you built that as a default, like what you're really going to build is like fold left, fold right. What you really want is like sort of the tree ones we built before, like fold L and R. You're going to fold N, L, R. Like, am I going to build every single one? Getting back to the student's original question, or what might be useful for this create free variables is, all right, so let me fold and you let me order the expressions like as we're going. Like, so when you start doing this, you're starting to ask yourself, like, how much am I really getting out of this if I got to build this fold custom order situation where, like it's kind of nice, like a ton of stuff just works, but then I've got to deal with, the hard cases and like, should I just build create free variables without fold at this point? The other one is that what if you want to build it with set union like I did, where you're unioning whole sets. So for example, the free variables return a set with it in it. The int will return an empty set, and things like let and function would have to do some interesting things where they're like unioning some things and removing other things. Do I have to rethink that with add if I'm going to do fold? Like, I don't think I necessarily have to, but at least when I started thinking about how you would do it with fold, you'd be passing in an empty set at the beginning, and there'd just be this like, you'd be traversing up and down the tree, and you would be just adding when you found a variable, doing nothing when you found like the int literal, and like just returning the set itself. And then, doing some combination of add or removes when you found like an mlet or function. And now I'm like, all right, so I want to build it this way. Do I have to build it the other way? I don't think so. I think you can still build it with the set union strategy, but it sort of calls for this. So now I'm kind of like, well, what is my fold really buying for me here? So bonus realities, I'm not even sure if my map and fold that I built are completely correct. I mean, the map at least passed the UW test, and I started down the fold road and got into this like, oh, just how specifically do I have to build fold to make it work for the function that I want to call it with? But I mean, map at least passed the UW's test, but unlike when I write something in ML after it works on a couple of things, I feel an incredible amount of security. I'm not completely sure that the tests that they've written or I've added in any way, shape, or form like test these things. And so that's just sort of a bonus reality. I thought I'd let you know, like, if that map I showed you is wrong, I'm not going to be stunned. There you go. So a bonus little thing to talk about is I had to add a case for fun challenge in my create free vars method because of the order in which map operates. Okay, so I had to add this thing where, like, if it's a fun, I like the fact, by the way, that it's called fun challenge. Like, it's a fun, like, functions are fun. Where I had to return, and this is again where I'm returning whole sets that I'm unioning, just the variables, it's the free variables of that function, just because of the order in which this works. So what I'm getting at here is this map of the body that happens first, which is totally reasonable, happens before the entire function itself is mapped on the way out. So this guy would find a fun challenge, not just a function. So I had to like deal with that as a bonus one. So like, not only does my map, my fold here or whatever have to, not only did I need to handle this case, like, now do I have to handle that also in my fold? And now that this is a set, like, do I have to run over it, or can I still use set union? I'm not saying that it's going to break because of fold. I think it'll be okay, but at least it's making me think about this whole thing. Like I said, I put in here, I thought for changing this order for like a nanosecond, so I wouldn't have to do this. And that's just crazy, because like, this is how map should work. And you start thinking, well, should I build map to go up and down? And now I'm like, all right, what am I doing here? Like, I've lost my mind. All this just so I cannot repeat the code in this one thing. So I will say is, like, if anybody wants to talk about this map and fold approach, please reach out to me. I built the map part, I built fold. I started to do it a little bit for this left-right thing, and like, it's 3 o'clock in the morning in the middle of a pandemic, so I'm like, I just need to shoot this video. But I got far enough to sort of feel like, one, it will work, and two, I need to just wait until this semester is over to press on. If anybody's interested, I'm happy to press on with you and sort of do this. I think it will work. My takeaway is that I think adding higher order functions to a data structure as fundamental as your abstract syntax tree for the programming language you're building would pay off, and that you would find more than a couple of uses for it. And you would have this situation where when you had map, you know, you would build at least this part of it just like this, right? Like, all right, map it and just change it. And maybe, you know, you would build fold such that it worked for the first feature you needed, maybe evaluation, or maybe this create free variables. And then it would pay off in other ways and you would use it. So my belief is that that would pay off in a number of different ways. It would at least pay off in the easy cases. Sometimes you might have a point where it's like, well, I've got fold, but it's just not going to work. I'm going to build it myself. And I think that's okay, right? But I do think it's worthwhile. Like, the person's question was excellent, so that's why I wanted to shoot this quick video. You know, how do I figure out a way to not just constantly be copying code all the time? And sometimes these higher order functions are a good functional programming language to do that.